All right, in this section, I'm not going to do the questions right off the bat because they're about multiple compositions. I thought it'd be better to just do the basic compositions, and then we can do that when we do the problems. So there's going to be kind of four types of ways of thinking about this: vertical shifts and vertical stretches, squeezes, and flips; horizontal shifts, horizontal stretches, squeezes, and flips. All right, so the first type here, the vertical shift. Now, when we're talking about vertical, what we are talking about is y values. So remember that a graph is the set of points that make an equation true, or in this case our equation is a function. So if we think of the little brown one on the top left as our base function that we start with, you'll notice that if you add, in this case 1, what you're doing is you're moving the entire graph up 1 unit because you're adding 1 to the y value of each coordinate. Where if you subtract 1, you're subtracting 1 from the y coordinate, so the whole thing is moving down. That's how you get vertical shifts, is that you're changing the y value of each coordinate. Now, if I want to do vertical stretches and squeezes, that means I'm multiplying the function by something. So notice that they all touch 0, because if you multiply a number times 0, you're still going to get 0. So for all of these, they stay anything that's on the x-axis stays anchored there. Now, if the number is bigger than 1, it stretches it away from the x-axis. So you see you get that orange one, 2 times f. It stretches all the values up 2. If you multiply it by half, it squeezes it towards. And then if you multiply it by -1, it flips it around the axis so that you get the same one just turned over. Now, you could put these together, so if you had like a -2, you would stretch it up and then flip it over, and you get the two of them together. So I like to think of it not as one number, -2. I think of it as two pieces. 2 stretches, negatives, flips. So I stretch and then flip, or flip and then stretch, whichever way you like. All right, so now the next one, this is horizontal shifts. Now this has to do with changing the domain of the function, because if you look at the little brown function, its domain goes from 0 to 1. Now if I want to find a new function, in this case h, where I add 1 to it, x plus 1, what that's going to do is it's going to change the domain. The domain goes from 0 to 1, so 0, if you just take x plus 1, set it equal to 0, you're going to get x minus 1. So the 0 moves over to -1. And the x plus 1 equals 1 moves over to 0. And in fact, if you take any point on the graph, set that x value of that coordinate to x plus 1, solve for it, it's going to shift it to the left 1 unit. Now if you take the function and inside the parentheses you change the domain by doing -1, you take x minus 1. I know that it can be anywhere between, it can be inside f, it can only be numbers from 0 to 1. So I take 0, solve it, and moves it to the right 1 unit. And if I take x minus 1, set equal to 1, it moves it to the right 1 unit, so I go to 2. So again, any x value on that brown one, if I set it equal to x minus 1, it shifts it 1 whole unit to the right. Now this is flips and shifts. Now these guys, it's a little bit different than the y values, but again it works like what we just did. You set what's inside the parentheses for the function. What's inside the function, you set it equal to an x value that's in the domain, and solve for x, and that gives you where the point shifts. So if I have minus x equals 0, of course that means it's still going to be 0. So again, just like the vertical one, anything that's on the y-axis is going to stay on the y-axis. It's going to be an anchor. So notice that if I take minus x and I go x minus x equals 1, I get minus 1. So a thing reflects it around the y-axis. So it flips it around the y-axis, right? If I take 2x and set it equal to 0, I get 0 because it's anchored. If I take 2x and set it equal to 1, I get a half. So notice that if the number is bigger than 1, then it squeezes it towards the y-axis. If I put 1/2 x, in other words, a number that's between 0 and 1, then it's going to stretch it out, because notice that if I take 1/2 0, it's anchored, so it still goes to 0. 1/2 x equals 1, and I solve for that, I get 2. So now the point at 1, 0 gets stretched out to 2, 0. So numbers that are between 0 and 1 stretch the graph. The numbers between are bigger than 1 to infinity, anything bigger than 1, 1 off to infinity, that squeezes it, and anything that's negative flips. So then, just like we did before, if I want to put them together, like if I had a -2, I would know it squeezes it and then flips it. If it was negative 1/2, then I know it stretches it, then flips it. So you can kind of start putting these things together.
How can you determine whether a function is odd or even from the formula of the function? Well, I guess we just have to look at the definition. If f of x is equal to f of minus x, then we know it's even function. If f of x is equal to minus f of negative x, then we know that it's an odd function. So what does that mean? I think an example would be a good way to look at it. So if I do 51, now I want to determine if this is odd or even. I would take g of minus x, plug that in. Now, since we know that when we raise something to the 4th power, that would be a negative times a negative times a negative times a negative, which would make it positive. So this is the same as this, 2x to the 4th, which is just g of x. Now, since minus g of minus x is equal to g of x, this implies that g of x is even. Okay? So if we try this problem, and we do the same thing, plug in negative x, we get 1 over negative x, 3 times negative x, which we can write as minus 1 over x minus 3x. Factor out the negative, that gives me 1 over x plus 3x. This thing here, the 1 over x plus 3x, that's just h, so we get minus h of x. So what does that mean? That means that h of x is equal to, multiply this over to the other side, minus h of minus x. So that implies that h of x is an odd function. We're going to describe how it is a transformation of the original function. So kind of the key is, what is the original function? So I think the key is, let me type this in correctly, is just the squared function, which is this one right here. Now, we can do this in pieces. So let's do the part inside first. What is that going to do? The x plus 3 is going to move it to the left. So let's show that. So we'll make g of x equal to x squared plus 3 squared. And you can see that the place where it turns, the vertex, is moved over 3 units. All right, so now let's do, what does the 5 do? The 5 changes it by squeezing it together and makes each point go up times 5. So let's pick a letter. H of x equals 5 x plus 3. So we're going to take the one we just did and transformation over. So we've moved it over 3 and we've squeezed it together. We've stretched it away from the x-axis, is what we're really doing, by 5. Now what does the minus 2 do? It drops it down. So let's pick another letter. We'll use K, I guess. So we have the previous one. Let's just do it this way this time. And then subtract 2 off of it. And so you can see that the function has slid over 3 to the right, stretched up by 5, and then dropped 2 units, and we have our final answer. All right, so let's try this function now. So h of x, so we want to put in the base function. So what would be the base function? In this case, it would be the just absolute value of x, like that. Now what happens to the absolute value? Let's see, let me slide this over a little. All right, so if we look at it, the first thing that's going to happen, let's do the inside, is I'm going to subtract 1. So I'm going to make a new function, and I'm going to take the h of x minus 1, and you can see what it's done is it's moved it 1 unit to the right. Now I'm going to take that function, the f, and I'm going to make a new function by taking f of x and adding 4. So this should go up 4 units, which it does. And so, in fact, we can pull it down, and you can see it even better that it's gone. So we moved it over 1 and up 5, and we have our function. The directions are to come up with the function from the graph. So it looks like a parabola. And so let's look at the parabola for a second. So I'll pull back GeoGebra. And if I put in the function f of x equals x squared, I get something like that. Now you notice that what happens here is that here is this spot 0, 0, and you have 1, 1 here and minus 1, 1 there. So this is 1 unit and 1 unit. Now if I go back to the drawing, I'll notice that what happens here is from 0, 0, I've gone over 1. Let's make this a bit wider and a bit redder. And I go down, and so then I go down. Why do they not want to stay the same? Right. So I go down this much right here. So I have that spot, which is over 1 and down 3. Now the key thing to remember is from this spot right here, remember we went up 1 and over 1 and up 1 over 1. So it doesn't look like it's been stretched or squeezed. We've just moved over 1 and down 1. So if I go back to GeoGebra, I want to do this function. I take the previous one, right? So let's do g of x. And I want to take f, and I want to move it over 1. And then I want to take the g and move that put in g of x, and I want to move it down 3. Now notice that it goes through the point 1, negative 3, and then 1 unit up and 1 unit over, which is exactly what we have here, right? We go over 1, down 3, and then these guys right here, right, this part right here goes up 1 over 1. So this point right here, up 1 over 1, up 1 over 1. So I think we do have our function, which is, let's do this. Let's be creative here, and I will turn this into, no, I'll do the next one. So let's put it all into 1 then. So let's call it k of x, and we will do x minus 1 squared minus 3, and we get that one there. Now, is that the same thing we just did? So just to make sure, let's go into settings, and we'll do style, and we'll make it a dashed line. We'll make it small dashes like that, and we'll make the thickness, make it real thick, I guess, and we'll make the color white. No, that's maybe not good enough. How about orange? Like that. So notice that if I zoom in, get rid of this thing, right? If you zoom in, you'll notice what you see is that there's orange underneath, or blue underneath the orange dots. So it is right on top of it. So that's exactly the same thing.